All right, so before we get started, I want everyone to take a moment. Close your eyes. We've been talking about velocity. I want you to try your best to get yourself as close to 0 meters per second as possible. I want you to see if you can get yourself as still as you humanly can. Right? Continue breathing. You don't have to stop breathing or anything, but try to get yourself as close to 0 meters per second as possible. Get yourself as centered and still as you can possibly be.
That's going to be so hard.
All right. Feel how still you are. That's 0 meters per second. That's 0 miles per hour. Now here's the thing. You exist in this state of quiet stillness on the surface of this beautiful planet. And every morning, just like it did yesterday and the day before, and just like it will tomorrow and the day after, the sun rises. The sun will rise tomorrow and the next day, because this earth is spinning on its axis. So you, sitting here on the crust of the earth, are also spinning on its axis. And you are spinning on the surface of the earth at a velocity of 1,000 miles per hour.
Startled me. I was like...
460 meters every second. Every second that goes by. Even when you are doing your most beautiful, still, stationary, meditative pose. And that was actually really beautiful. That was very well done. Nicely done, y'all. I appreciate that. Even when you are at your stillest, you are still traveling 460 meters each second. And that's not all, because that's just the Earth spinning on its axis. But not only does the sun rise and set every day, but also the seasons come and go. Fall turns to winter, turns to spring, to summer, over and over again. Because the Earth is not just spinning on its axis, it is in orbit around our beautiful sun called Sol. And we are in orbit around Sol, traveling at 67,000 miles per hour. So 67,000 miles per hour. That is almost 30,000 meters every single second. So that's 30 kilometers every second that goes by.
How many miles exactly was
That is 67,000 miles per hour.
Wait, do I have to write this down?
You don't have to write down these exact numbers, but the concept here
Wait, how?
is important. So you are hurtling through space.
Every second?
Every second, you're traveling 30 kilometers. And that's, so we got the Earth spinning, and then we have the fact that the Earth is also orbiting the sun as it's spinning. But then the sun, with the Earth around it, is also in an orbit. It's orbiting around a black hole at the center of our galaxy. And the sun is orbiting this black hole incredibly fast. Almost 500,000 miles per hour, right? It's 483,000 miles per hour, so it's almost 500,000 miles per hour. 200,000 meters every single second. The Earth, or the sun, and with it the Earth, and with it you, are orbiting around this black hole at the center of the Milky Way galaxy. But the exact numbers aren't what's important here. The thing that's important here is to acknowledge, hey, that's real fast. We are going incredibly fast through space. But when I give you a problem that's like, oh, like, Sylvie is hopping 10 meters down the lower yard, and it took 3.5 seconds. How fast is Sylvie going? No one wants to be thinking about the expansion of the universe, or our orbit around the black hole, or whether our orbit around the sun is in the same direction or the opposite direction of the orbit around the black hole, in order to solve a question about how fast you're going. When I ask you to go measure your cat moving towards you, you shouldn't have to think about how fast the Earth is spinning on its axis to solve that problem. So And the solution is a little silly, honestly, if you think about it. It's that we just pick something and we pretend that thing isn't moving. So if you're measuring yourself running down the lower yard, then before we do that problem, there's a little step, a 0th step, that we all just kind of do automatically, which is to say, hey, when we're solving this problem, let's just pretend that the lower yard isn't moving. Right, the lower yard's not moving. Sylvie ran down it. It took Sylvie 3 seconds. So Sylvie's velocity is 3 1/3 meters per second. Done. And we don't bother thinking about the expansion of the universe or the movement of heavenly spheres when we're solving simple problems. I ask you to measure your pets at home. You measure your dog moving across the room. Part of that is we just pretend, let's just pretend the room isn't moving. Because the problem's a lot easier if we don't think about your room literally spinning on the Earth's axis when we're trying to solve it. So this is the first solution. It's called a frame of reference. The frame of reference is just something we pretend is totally stationary. Most of the time, your frame of reference is going to be the surface of the Earth. Sometimes your life is made much easier if you pretend the frame of reference is something else. So for example, many years ago, we had to change the class trip, and we ended up taking all the 7th graders on a train for like several hours. We had a train full of 7th graders, and on that train there were 7th graders, tossing a ball back and forth. If I want to know about the movement of that ball, it's probably easiest for me to say, let's just pretend the train isn't moving, and solve the problem just thinking about the ball. And that'll make your life much easier than if you're thinking, oh, is the ball moving in the same direction as the train or the opposite direction of the train?
Wait, so the frame of reference is the thing that you pretend isn't moving.
That we just pretend is stationary. This makes our life much easier, but it does also introduce a kind of weird truth, which is that there is no real difference between something that is totally stationary and something that is moving at a constant velocity. If I say, Alice, you are totally still, you are moving 0 meters per second, or I say, Alice, you are hurtling around on the surface of the Earth at 1,000 miles an hour, both of those statements are equally true. And Alice can just sit there for as long as she feels like. There is no enormous hand spinning the Earth continuously on its axis like somebody balancing a basketball on their finger. Have y'all seen those cat toys where there's like a circle with a ball stuck in it?
Oh yeah.
There is no giant cosmic cat batting the Earth around its orbit, or keeping the sun moving around this black hole at the center of the Milky Way. An object does not need something pushing or pulling on it for it to keep moving. You only need something pushing or pulling on you to stop moving, or to change your moving, or to speed up, or to change directions. So if you want to change what you're doing, then we need what's called a force, which is just a push or a pull on an object. But for it to keep doing what it's doing, nothing is required. This is called the law of inertia. Inertia is just an object's tendency to keep doing what it's doing. And in my experience, people are totally okay with inertia when it comes to things that are stationary. Nobody is upset about the idea that this water bottle will continue to be a water bottle there until somebody pushes or pulls on it. People feel a lot more uncomfortable with the idea of things continuing to move. And what I want to remind you of is fundamentally there isn't a real difference between something that is 0 miles per hour and something that is 1,000 miles per hour. Or something that is 0 meters per second and something that's 200,000 meters per second. It's the same object, just with a different frame of reference. We're going to get into much more detail about this on Monday or Tuesday, whenever I get to see you next, when we start talking about acceleration. But for now, I just wanted to plant this idea of frame of reference and also this idea of inertia in your head.